First of all, energy. Energy is a physical quantity, and we abbreviate energy with the letter E. The unit we use for energy is joules. That's the standard unit for energy. Next to joules, we also use kilojoules and kilowatt hours. The definition of energy is the ability to do work. Now, it's a very general definition. And what do we mean with work is that when you see something happening or you feel something, then that might be proof that we're dealing with energy, such as a lamp emits light. You can see the light. Some object feels hot or is sending out heat energy. Another example is, of course, electrical energy. You can see the effect of electricity. For instance, when we see lightning, when there is a thunderstorm. And then also a very important energy form is movement. When we see something moving or somebody moving, then that person has movement energy. And another word for movement energy is kinetic energy. In some cases, you don't see the energy, but the energy is still there. And then we talk about stored energy. Therefore, the general definition is energy is the ability to do work. Okay? Now we see an example of energy conversions. For instance, here, this hammer is hitting the nail. But when we look at when we look at the situation in stages, you could say that when the hammer is lifted, you cannot directly see energy yet, but there is potential energy. And then the hammer starts to move downwards. Then we say you will have kinetic energy. Then the hammer hits the nail, and then we call that mechanical energy or impact energy. There we go. So in these three stages, energy is converted from potential to kinetic to mechanical energy. Okay, when we look at the person here holding the bow, you see that when he pulls the string, he basically adds potential energy to the bow. Then when he releases the string, the arrow will fly away, and then you have kinetic energy. Another example. Here we see a tree, an apple tree, and when an apple falls from the tree, there is an energy conversions in three stages. First, the apple has gravitational energy, which is potential energy. Then, when it falls, the potential energy is converted into kinetic energy, which means that the apple will fall and its velocity will become more. And then when the apple hits the ground, you've got impact energy. In physics, we can also explain these three stages with help of a formula. When we look at gravitational energy, then you can calculate the amount of gravitational energy when you know the object's mass, you know the gravity constant, and you know the height the apple is hanging. All these three together, multiplied, will give you the amount of joules, which stands for the gravitational energy. Then, when the apple falls, this amount of energy is converted into kinetic energy. At the moment that the apple hits the floor, the kinetic energy is converted into the impact energy. On Google Classroom, you find a digital reader. In this digital reader, you can find a small text on page 4. It's this text, and as you can see, there are two words missing. It's the type of energy needs to be filled in. Please read this text carefully and try to fill in the correct energy type at these two places. Did you manage to fill in the correct energy type? Let's have a look. Put the pencil at the edge of the desk and push it off to the floor. The moving pencil has kinetic energy. Now, why does it have kinetic energy? You can see it here in the text. The moving pencil has, the word moving points out that the pen is falling. And while it's falling, the potential energy the pen has is converted into kinetic energy. So basically, the amount of potential energy becomes less, and the amount of kinetic energy becomes more. So this is not correct, actually. You should say the moving pencil is gaining kinetic energy in this case. Now pick up the pencil and put it back on the desk. You use your own energy to lift and move the pencil. Moving it higher than the floor adds energy to it. As it rests on the desk, the pencil has potential energy. The higher you put your pencil, when you put your pencil on the desk, there is an amount of potential energy. And how do we know that? Because when we push off the pencil again, it will start to move downwards. So there is a potential energy. When you put your pen higher, even higher on a shelf, then it has even more potential energy, and it's able to fall down and eventually reach a higher velocity, more kinetic energy.